Yeah, welcome back. In this class, we are going to see the design rules. Okay, don't forget here the design rules. What are the design rules we are going to study about means we are going to study the design rules for layout. Especially, we are going to talk about focus about lambda based design rules. First of all, let me explain what is the significance of design rules. If you observe that the design rules are effectively used to interface between system designer and fabricate engineer. That means if the system designer is perfectly okay ready the blueprint of the design, that means the layout of the design, then the fabricate engineer it is very easy to design it. Is it clear? That is why the design rules are effectively used to interface between system designer and fabricate engineer. Coming to the another most important significance of design rules, if you observe that design rules are very vitally used to translate stick diagram information to layout. That means to convert the design in the geometrical representation. That means we know that very well stick diagram consists of what layers information in the form of color code or monochrome encoding. That color code or for that monochrome encoding, if we apply some geometrics based on the design rules, then it is going to be turns into layout. Is it clear? Now you can observe who designed this who developed these design rules. Mid and Conway developed these design rules. First of all, let me explain. Okay, basically there are two design rules. There are two types of design rules. The first one is Lambda-based design rules, and the second one is micrometer-based design rules. Is it clear? Now, first of all, we will focus about this one. Okay, later, depending upon the request of the viewers, then I will talk about this one also. Then, first of all, I will focus about this one, lambda-based design rules. Now, you know very well, the lambda-based design rules are developed by Mid and Conway. Okay, who developed this lambda-based design rule? Absolutely. Who developed? Mid and Conway developed these design rules. Okay, therefore these lambda based design rules are also known as Mid and Conway design rules. Okay, all the dimensions in the lambda based design rules are measured with the basic unit which is known as lambda. Is it clear? Once again I'm telling that all the dimensions are going to be measured with the basic unit which is known as lambda. Is it clear? Therefore, this is also known as what? Lambda based design rules. I hope that are you clear. Is it understood? Now let me explain how many types of design rules, that means in lambda based how many types are there. Now I will talk about the first one. If you observe the first one, we are having the design rules for wires. Later we are having the design rules for transistors. Later we are having the design rules for contact cuts. That means contacts. You may also call contact cuts. And special design rules are there. Okay, for CMOS. Okay, we can call it as CMOS based lambda design rules. CMOS based lambda design rules. I hope that are you clear. Okay, then that is a very important thing you have to remember. In this class we will focus on the design rules of wire. Okay, later we will talk about the transistors, contact cuts, and CMOS based lambda design rules. Is it clear? Now first of all, you can observe that I am talking about the design rules of wires. Now will you please tell me how many wires are there? You may call these wires as layers. Okay, will you please tell me how many layers are there? Yeah, absolutely. How many layers are there? 3 layers are there. Is it clear? Most probably. The first layer is what? Poly. The second layer is what? Diffusion. Okay, don't forget, while coming to the lambda based design rules, this diffusion is also called as thin ox. Is it clear? That means thin oxide. Then finally poly diffusion, and you are having a metal. These are the 3 layers we are having. But if you observe that this metal is divided into 2 layers, metal 1 and metal 2. I hope that are you clear. Okay, now first of all you have to observe very importantly. Here the lambda based design rules are going to be focused especially on width. Is it clear? They are going to be focused on width. They are not going to be concentrate on length. Why? Because if you fix the length, then it is highly impossible to you to extend the layer. Now, what is the minimum width of polysilicon? 2 lambda is the minimum width of polysilicon. What is the minimum width of diffusion? That is also 2 lambda. Okay, the minimum width of diffusion is also what? 2 lambda. What is the minimum width of metal 1? That is 3 lambda. What is the minimum width of metal 2 innocence? That is 4 lambda. Okay, this is about the minimum width of each and every layer. Poly is 2 lambda and diffusion is 2 lambda, metal 1 is 3 lambda and metal 2 is 4 lambda. Now we will focus on two different or two similar layers if you observe that very clearly. Now if you are having poly, then what is the minimum spacing between these two innocence? 2 lambda it is. Then if you are having diffusion, don't forget diffusion, we are having two types, N diffusion or P diffusion. Whatever may be the diffusion, okay, the spacing between the two diffusion is 3 lambda. That is very important point you have to remember. And if you talk about the spacing between poly and diffusion, okay, then it is 1 lambda. Is it clear? Once again I'm telling that poly to poly 2 lambda, diffusion to diffusion 3 lambda, poly to diffusion is 1 lambda. But what about the metal 1 to metal 1? If you observe that for metal 1 to metal 1, it is 3 lambda. Whereas for metal 2 to metal 2, okay, what is the minimum width of metal 2? 4 lambda. Therefore, they said for easy purpose, the spacing between this also what? 4 lambda. Is it clear, all of you? Okay. And one more important thing I have to tell. Okay, in this, you are having a contact area. Okay, you are having a contact area. And one more important thing you have to remember here, after contact area you are having a contact cut. Is it clear? This contact area is represented with a square. Okay, this contact area is represented with a square. I will draw very cleanly. Okay, this contact area is going to be represented with a square. Is it understood? And one more important point is, since you are going to draw about a square, it consists of a width and also it consists of a length. What is the size of this contact area innocence? The size of contact area is 4 lambda by 4 lambda. Is it understood? That means 4 lambda by 4 lambda. Is it clear? Now if you talk about the contact cut, don't forget in contact area definitely you should have a metal and the surrounding layer, one more layer, whatever it may be. Is it understood? And if you talk about contact cut, very importantly, the contact it is going to be represented with a square and definitely it should be shade. Is it clear, all of you? And it is also is having a size. What is the width of this is, if somebody asks you, the width of this is 2 lambda. What is the length means? That is also what? 2 lambda. The length also 2 lambda. Therefore, the contact cut is 2 lambda by 2 lambda. I hope that are you clear, all of you? Now shall we see some pictorial representation of this design rules for wires. Don't forget this contact area and contact cut. This is the pictorial representation. And I am going to show the pictorial representation of layers. Is it understood? Then you can observe very easily, then you can grasp very easily. Therefore, please observe very carefully. Is it understood? Okay. Now you can see the pictorial representation of it. We already discussed what is the minimum width of a diffusion, that is 2 lambda. It may be N diffusion or it may be P diffusion. Now you can observe what is the minimum width of polysilicon, that is 2 lambda. Is it clear? What is the minimum width of metal 1? Okay, that is 3 lambda. What is the minimum width of metal 2? That is 4 lambda. Now you can observe that for diffusion to diffusion, what is the minimum width? You can observe 3 lambda. Then for diffusion to polysilicon, what is the minimum width, minimum spacing, that 1 lambda. For poly to poly, what is the minimum spacing? 2 lambda. Now you can observe that for metal 1 to metal 1, what is the minimum space? 3 lambda. For metal 2 to metal 2, what is the minimum space? You can observe, okay, sorry, not this one, metal 2 to metal 2, what is the minimum space there? I think so it is not clearly appeared for you. Okay, now you can see that is 4 lambda. I hope that are you clear. Now once again I'm telling to each and everyone, this is a pictorial representation. You can talk about it. If you are having any doubts, you can ask. Okay, one more time I'm telling to each and everyone. Is it clear? Now you can observe that what is the minimum width of diffusion? 2 lambda. Is it clear? Then what is the minimum width of what is called polysilicon? You can observe 2 lambda. What is the minimum width of metal 1? That is 3 lambda. What is the minimum width of metal 2? That is 4 lambda. Now what is the spacing, minimum spacing between diffusion to diffusion? Either maybe n diffusion or p diffusion, that is what? 3 lambda. Okay, then diffusion, any diffusion, either n or p diffusion to polysilicon, that is what? Absolutely 1 lambda. Then poly to poly, it is what? 2 lambda. Then if you observe that for metal 1 to metal 1, what is that? 3 lambda. For metal 2 to metal 2, what is that? 4 lambda. Is it clear? That's it, guys. These are the design rules for wires. If you are having any queries, you may ask and please comment. Thank you very much. Have a nice day.